All right, the section 5.4 is about the law of sines. And before we get to law of sines, though, law of sines is based on this other way we can use trig now to find the area of any triangle. It's called the side angle side area formula. You may remember that finding the area of a triangle, you need to know the length of the base, and you need to know this height. And the height is some sort of perpendicular length. It has to be perpendicular to the base. And let's say we don't know that. Say we know the lengths of the sides here. Yeah, in fact, whoops. In fact, I am going to make an example up where we have numbers. We'll come back to this generic one in a second. But let's make up one where we don't know, where we do know the numbers, but we don't know the height. Okay, and this doesn't have to be a right triangle. This could be any triangle. Let's say we know this entire side is, oh, I don't know, 13. Let's hope I make an example that looks good. We don't know that. Again, that could be anything. Or, you know, that I don't know what that is. This is not a right triangle, so I don't want this to be 5 and 12. Let's make it like, oh, I don't know. If that's 13, this side looks like it might be 11, and let's call that side 6. Okay, this is definitely not a right triangle. I am going to call this C again, just for reference. Okay, well, I know the area of this triangle, the area of the entire triangle, would be half times the base times the height, but I don't know the height. But notice that C is in a right triangle here with H and 11. I can say something about C because I know in this triangle with C, and I talk about this as angle C, the sine C is the opposite side divided by the hypotenuse. That's just H over 11. So if I knew this angle C, I could find H. I could then say H is 11 times the sine of C. If I multiply both sides by 11. And that's sort of the heart of why, where the law of sines is eventually going to come from. That sine helps us find this opposite length. Sine helps us with basically verticals. Remember, sine was the y-coordinate back in coordinate days when we were studying trig. So the area of this triangle is a half times 13. Now this is even though we found C kind of in this one little part of this triangle here, it's the same angle C whether we're talking about the entire huge triangle, ABC, or just the little triangle that's on this side. Anyway, so yeah, this sine of C is sine of C just based on the angle. It has nothing really to do with the size of the triangle in and of itself. Oh, and I forgot to mention that, yes, in order for this to work, we do actually have to know this degree. Oh, I don't know. I'm making this up. I probably should be more careful because with a 6 and 11 and a 13, I should actually know what that angle is, of course, from law of cosines. But for the sake of this example, I'm just going to make this up. Let's say that's about 29 degrees. And of course, that would be given, so sorry about that. So here, that would be 11 times the sine of 29. I'll do more examples where all the given is clear. All right, so H here is 11 times the sine of 29. And so now I've just got numbers. There's no variables left. All I really needed for this, well, I didn't even need the 6. I needed the 13, I need the 11, I need the 29. So if we have any triangle, if I know this side, and I know this side, and I know this angle, that's enough information to find the area of this triangle, which is kind of a new concept. Okay, so let me just do this. I should probably actually do it if I went to the trouble this far already. Half times 13 times 11. That's 71.5 sine 29, which is approximately altogether 34.66. And we are talking about area now. We haven't done area in a long time, so that's in square units. Okay, so back to this example. If I know the angle C, and I know the length of A and the length of B, I can find the area of this triangle. Actually, I'm going to call this, I'll just tell you what this is first. Side angle side area formula. This pen isn't nearly as fast as a real pen. Oh man, look at that wonderful handwriting. Look like a first grader. Okay, SAS area formula in general is that the area of this triangle this would have been a lot more helpful if you were back in like geometry and you needed to find these things and you didn't know H and you're trying to solve for it using trig and all that kind of stuff. The area of triangle ABC. So the big thing, and that's it's a little weird here because it seems like part of your thinking probably stopped at this line here that's labeled H, but really we're finding the whole thing because remember this B is the length B all the way to there. Don't need to know C actually. The area of triangle ABC is 1/2. That's from the old half base times height formula is where that came from. A times B times the sine of C. Now you might think, well, why don't we call that law of cosines? It's so cool. Well, it's not the law of cosines. It gets us to the law of cosines. You think this is cool? You haven't seen anything yet. So C is unnecessary. That C is unnecessary. This C is completely necessary. And also H is unnecessary. H was kind of used in the development of the formula. But what's really needed here is the A, the B, and the C. Oh, it looks like my time is up. Okay, from all that, if we're saying that in any triangle, you can find the area. This was A, this was B, and this was C. Saying the area equals half AB cosine, AB sine C, half AB sine C. Well, isn't that the same area? And I could use A and B and this angle, the angle between them, like side angle side, and find the area. I should also be able to use side angle side up here and find the same area. That would be half AC. That's a C. Yep, sine B. Or I could use the other side angle side, the one over here at this corner. Half BC sine A. Well, this proof is really cool. People get excited about this proof. Watch what's going to happen next. This is the basis of what we're going to call the law of sines. So in this triangle, I'm talking about the sines of everything. I'm talking about the sines of each angle. There's a half everywhere. I could multiply all these. I'm going to triple solve this at once. Ready? My hand will never leave my arm. Okay. Multiply everything by 2. So I could say AB sine C equals AC sine B equals BC sine A. I guess I do have to write all that out, don't I? AB sine C. This means the same thing as the equation above. I'm just multiplying everything by 2. That means, so basically now each one of these stands for the double of the area of the triangle, which is okay. That's still all equal. I can just get the pen to cooperate here. And that's BC sine A. Maybe. Okay. And if I divide everything here by the product of A times B times C, it'll still be equal. A, B, C. Divide by, and you might be thinking, Mr. Craig, you going crazy, man. What'd you do that for? Okay, watch. Divide everything by ABC. Here, the A's and the B's cancel. Here, the A's and the C's cancel. And look what's left. Aha, see that? And here, the B's and the C's cancel. See that? See that? So let me just rewrite this. Are you ready for this? Drum roll, please. Sine C over C equals sine B over B in the same triangle. And that equals, I mean, this is so great. This could almost be the definition of sine. It's so great, but it would have been really hard to explain to people. Anyway, that, my friends, is what we call the law of sines because it is so good and so simple and so useful. Okay? Stare at that for a good long time. That's awesome. So what's that good for? Well, that would be good if you knew all the angles of a triangle and you knew any one of the sides, you could find the missing sides. For example, let's say we have, I don't know, a side of 4 here. And let's just say I know two of the angles, because if I know 2, I know 3 actually, right? Say I have a 40-degree angle here, and boy, this is really bad, isn't it? And a 70-degree angle here. Well, without too much work, I can figure out what this is. That adds it to 110. So, oh gosh, look, we're talking about isosceles. Well, that's no fun. Let's make life a little more interesting here. Let's say that's 75. Okay, and then I can figure out pretty quickly that the last angle in the triangle has to be 65. Okay, so if that's all I knew, let's call this A and B and C. So in keeping with the normal scheme of things, now I know things like the sine of 40 over 4 in this triangle is going to equal the sine of, let's just do B next, just to be in keeping with the alphabet, sine of B over B. Well, I know what B is. B is 75. So I can use cross multiplication, and I can figure out that B times the sine of 40 equals 4 times the sine of 75. And so yeah, B is this huge mess. Now if you want to just do it all at once in the calculator, which I like to do, 4 sine 75 over sine 40 and on the calculator I get really close to 6, and I can figure out B. And guess what? That's the same thing as sine C over C. Sine of 65 over sine C over C. And that equals our same one over here, sine of 40 over 4. Keep these separate here. So yeah, this is going to turn out the same way. C times sine 40 equals 4 times the sine of 65. Divide both sides by sine 40. Oh yeah, here's another common mistake I just thought of. Some people see this sign divided by this sign, they cross out sine. They think like this is a number and this is like a number, and they just divide. Oh yeah, I can cancel sine and sine and take 4 times 65 over 4. Something crazy like that. Sine of 65 is a number. It's a number that's the ratio of opposite of hypotenuse in a right triangle 65, or is the coordinate of the unit circle when they've got a central angle of 65. Sine of 65 is a number. Sine on its own is, it's a function. It's not something that can be sort of divided off by each side. Okay, so back to the calculator. C turns out to be something like 5.64. Okay, and that's some great applications of the law of sines. So far we've been able to use law of sines when we're talking about side angle side type of stuff, and that has only worked because we know that side angle side is a way to prove the triangles are congruent. Well, you can also use the law of sines in the side-side angle condition. Now, side-side angle is kind of tricky because it doesn't prove that triangles are congruent. You could possibly have, if you remember from geometry, 2 different triangles that have the same side-side angles congruent in both triangles, that they're not actually congruent. So most of the time, this doesn't actually work. The only way side-side angle can be trusted is if you know which side is bigger than the other, and they write it this way sometimes. I call it big side, little side angle. So if you know in a triangle that one side is bigger than another, and it's the smaller side that's next to the angle that you know, I know that sounds like a lot of requirements, but it's actually kind of helpful because it's a new